Like hell, well, good night. Today we're going to talk about my Pia. My name is Ricardo Martin Rivera. The professor in charge of this assignment is Maria Fernanda Retana Betancourt, and my whole name is Ricardo Martin Rivera, as I said before. And, well, let's start with my investigation about the granular activated carbon. So, and as an absorption and filtration medium. Well, the absorptive capacity of GAC. The granular activated carbon GAC is a hybrid mixture of a wide variety of graphite platelets that are interconnected by non-graphite carbon bonding. So the absorptive capacity of GAC makes it ideal for removing a variety of contaminants from water, air, liquids, and even gases. So the United States Environmental Protection Agency, the EPA, consider absorption by GAC to be the best available technology removing many organic materials in water surfaces. Well, so the disinfection byproduct, the DBPS, are associated with chlorine and alternative disinfectants. This means that the algal toxins such as microcystin, LR, endocrine disrupting compounds, pharmaceutical and personal care products, even taste and odor causing compounds will be eliminated or extracted by the surface area or the volume that is contaminated with everything that is mentioned. So this is the huge capacity of the GAC. So how is the production? Well, the activated carbon production. The activated carbons are produced from some of carbon-rich precursors, materials like anthracite, lignite, wood, coconut shells, and peat. So these materials made activated carbon by either thermal or chemical activation processes. The thermal treatment includes steam gasification, and their activation can produce a less costly product compared to reagglomeration. Well, I'm gonna talk about what does this mean, right? Well, what's reagglomeration first of all? Well, we need to get to know that this method involves two more steps compared to the direct method: pulverizing and agglomeration. So the reagglomerated carbons tend to have a more homogeneous pore structure that can be better for certain organic contaminant removal. So these platelets are arranged randomly within the GAC particle to provide the extensive internal structure. What does it mean? That the granular activated carbon is like 1000 times better than the simple carbon and the activated carbon. Only by these two more steps that are involved in the process. So the simple activated carbon, it has a processes also yields a structure with a broad range of pore sizes. Well, these pores or voids, as you want to name it, in conjunction with the graphite platelets, generate a material with the strongest physical absorption forces available in an absorbent coupled with the largest volume to store the absorbed materials. What does it mean? That right there, as the transport port is mentioned right here, right here, the transport port. There they can be attached some particles from the medium that you use to work it. So, what is absorption? Well, the absorption results from the interaction of electronic structure of an absorbent, such as activated carbon with the absorbate, such as states and other causing compound like jasmine. So, molecular compounds organically attract to the porous surface area of the carbon. What does it mean? That this process is the one that is in charge of that the water that you are consuming, once you add the activated carbon, doesn't have any kind of odor later, because this happens, right? So there you have your carbon. The absorption is like a particle is attracted to be in the surface, not inside. It's attracted to be in the surface of the porous that is generated. That's why it is an activated carbon, because it has many pores. So right here we're gonna have many certain particles of everything you want to retire from the water. So next, gag filtration. Gag has also shown to be an effective physical filtration medium in water treatment plants and has to be at the benefit of providing water quality protection by absorption of other compounds or chemical contaminants. So this because suitable disinfectants such as chlorine will rapidly react over gag, leaving no disinfection residue. So the application of the last one is that gag can be used in water treatment, swimming pools, wastewater treatment, or industrial water processing. Waste gas treatment, mercury removal in industrial gases, food and beverage, cold recovery, and even medical uses. Well, this is everything for me. Thank you for your attention. These are the bibliography I researched in these two links, and also in these two books that I work really well with them. So thank you for your attention. My name is Ricardo Marroquin. I am at your service.